All right, today we are going to look at adding, subtracting, scientific notation, my friends. Adding and subtracting. All right, so let's just look at, we'll take like a very easy question here. Let's do 4 times 10 to the third, and let's add it to, let's just say 2 times 10 to the fourth. Let's do 2 times 10 squared, okay? All right. This is completely different than how you would multiply or divide, all right? The reason being is because, well, if you were to put these in standard form, you can't just rearrange it and write 4 times 2 times 10 to the third times 10 squared, because you're not multiplying all this together anymore. You're adding. So you couldn't say 4 times 10 squared plus 10 to the third plus 10 squared. Like if you had an easier question, if we had 1 times 2 plus 3, that is not the same thing as 3 times 1 plus 2, or 3 times 2 plus 1. I think that actually gave you the correct answer. I mean, the same answer, but it just happened to work out like that. 1 times 2 is 2. 2 plus 3 would give you 5. 3 times 2 is 6. 6 plus 1 gives you 7. You can't rearrange any which way you want to anymore because you have that addition symbol in there. So you can't rewrite it like this. All right? So we're going to have to figure out another way. Why don't we just turn them both into standard form and then add them and then put it back into scientific notation? There are other methods to answer this question. I think kids find this way to be the easiest. 4 times 10 to the third, that would give you 4, and then you move the decimal 3 times in the direction that would make it a big number. Don't look at it in terms of left and right, and don't just add 3 zeros. In this case you are, but that's just how it works out for this question. It's not going to work like that every time. So you move it 3 times. Now, 2 times 10 squared, you're going to move the decimal 2 times in the direction that would make it a big number. And make sure you put your decimals there because that's going to help you out. You've got to line up the decimals whenever you're adding or subtracting. All right? So you are going to line up your decimals here. And it just so happens that the decimals here are at the end. You'd have 0, 0, 2, 4. So that's 4,200. And now we're going to write that in scientific notation. We would move the decimal 1, 2, 3 times. That'd be 4.2. And how many times we move the decimal? That gives us our exponent. And since that's a big number, it gets a positive exponent. Moving right along. If you were to rearrange the sentence, let's do that for just a second, just so you see it's the wrong answer, all right? If we were to rearrange the sentence like we did with multiplication, like we had 4 times 2, and then you add it to 10 to the third times 10 to the second. 4 times 2 would give you 8. 10 to the third times 10 squared would be times 10 to the fifth. 8 times 10 to the fifth is a lot different than 4.2 times 10 to the third. This is going to be up in the number of hundreds. That's 800,000. This right here is 4,200. So you can't just rearrange any which way you want to. All right, little children. Moving on. Let's take something such as this. Let's do 5.3 times 10 to the fifth, and let's add it to 2.1 times 10 squared. All right, again, rewrite them in standard form. 5.3 times 10 to the fifth. You're going to move that decimal 5 times. You don't just add 5 zeros. 1, 2, 3, 4, 5. 2.1 times 10 squared is going to be, you're going to move it 2 times. So here you've got to line up the decimals. You don't line up the first 2 whole numbers. All right? You line up the decimals, my friends. 5, 3, 0, 0, 0, 0, and you add that to 210. Running out of room here. That would give you 0.01235. Now, let me write this over here. 530210. This is a kind of a tricky number that we would put into scientific notation. All right, you got to go to the last whole number. So I'm going to write my answer here in black. You're going to move the decimal into between the first two whole numbers, or the first two numbers would be 5.3, but you've got to leave on the 0, the 2, and the 1. You can drop that last 0, but you've got to keep all the numbers up until the last whole number there. And how many times you move the decimal would be 1, 2, 3, 4, 5. It'd be 10 to the 5th. You're always going to get when you have positive numbers, you're always going to get the larger exponent, or at least you should. Most of the times you will. All right. All right. They are going to get a little bit just different. I mean, the logic is still going to be the same. It's just they're going to look a little bit. It's going to look like it's a little bit harder, but it's really not that bad. All right. Let's take 2.7 times 10 to the negative 3, and let's add it to 5.49 times 10 to the negative 6th. So we would, that's a 3. You'd have 2.7, and you're going to move that decimal in the direction that would give you a small number. 1, 2, 3, decimal. All right. We're going to add that to 5.49 times 10 to the negative 6. You're going to move that decimal 6 times, so you get 0.0000549. All right, let's see. You got to move that 6 times. 1, 2, 3, 4, 5, 6. Looks good. Now you got to line up those decimals. You get 0.0027, and we're going to add that to 0.0000549. 0.0270549. Now we got to put that number into scientific notation. We're going to move that decimal 1, 2, 3 times, so you get 2.70549. And how many times you move that decimal is going to give you your exponent. No, this is not our correct answer. What's wrong with this? If you can say, if you're the first person to say, Mr. Portman, I figure out what was wrong with example number 3, I'll give you bonus points. Shows me you watched the video, shows me you're paying attention. What's wrong with this is you didn't put the negative symbol in there for the exponent. All right, it would be 10 to the negative 3, because this is a small number, little children. And guys, subtraction is the same thing. All right, subtraction, you would just, instead of add those two numbers, you're going to subtract them. And that gets to be kind of, let's say we were subtracting these. That gets to be quite ugly. I'm not going to give you anything too hard to do like this, but if you're going to subtract, you would add zeros right here. All right? So, you would have to borrow and all that sort of stuff. I'm not going to give you anything quite this hard. I mean, that's a calculator question. That's the other drawback from using this method. There is another method in which we could use, and I'll show it to you. I might show it to you. Depends on how well we're picking this up. But the other drawback to this is if we had 10 to the negative 20 and this was 10 to the negative 45. Like, I don't want to write those in standard form. You know what I mean? Like, that would take way too long. The whole reason we do scientific notation is so we don't have to write it in standard form. Okay? So, but with adding and subtracting, that's what you're going to do. Is you're going to just put them in standard form. SF is standard form. Okay? Not San Francisco. Put in standard form. Add or subtract. Make sure you line up the decimals. And then 3, put it back in the sign notation. put it back in a scientific notation. All right, I'll do another video in which we do a subtraction one. I'll see if I can add it to this, just because I've got kids about to walk in my room. So if you have any more questions, we'll do some examples with this. You'll be doing just fine, okay? All right, do the next thing. I believe in you.